So lately we've been talking about different methods for determining limits. And the first method that we really started talking about is called the numerical method, where we make a table of values, and what we do is we plug in those numbers that we choose as we get closer to what we're looking for. We're trying to hone in on where that value actually is, and we just see what happens. And we generally use the calculator just to plug in numbers and see what happens. But the other method that we tend to use a lot is the graphical method. And a lot of times with that, we're given a graph to actually look at. The graph's already done for us, or in some cases, I know you guys have gone through and just to check yourself, you've used a graphing calculator or something else to kind of sketch what the graph looks like so that you can get an idea. But here's the thing. When you're looking at a calculator, all it's doing is just plugging in numbers. It's still doing the numerical method. It's just doing it a lot faster than you would. So the question then becomes, is there any other method? Well, of course there is. There's another really good method, which we'll call the analytical method, which basically uses algebra and calculus skills to try to figure out the limit of a value. And so the question you might ask yourself is, well, if the calculator is just doing the numerical method, or all I have to do is sketch a graph, why do I need another method to try to determine a limit? And so I'm going to just briefly touch on that. And I'm going to use a very similar example to the one I actually used in the written notes, just because it really elaborates on what I'm exactly getting at. So the one I'm using here is, if you guys can see down here at the bottom, it's the square root of x squared plus 9. Then you're going to subtract 3, and you're going to divide all that by x squared. And so you're going to kind of look at this graph right here, and if you, I'll just kind of touch on it so you guys can see. I'm going to find the limit as x approaches 0, which you see there's a dot there, and it kind of tells me that there's something going on here. It says it's an extremum. It's something unusual. It's an extreme value there, really, really close to 0. And so most people are just going to look at this graph, and they're going to say, oh, it approaches whatever that little dot is. Well, watch what happens as I zoom in. Okay, so notice to begin with, it kind of looks a bit like a straight line. It's got a little bit of a curve to it, but the more I zoom in, the more it starts to look a little bit curved. And as I get closer and closer and closer, it kind of straightens out up here at the top. And I'm going to keep on zooming in until it kind of stops me. It's been doing that a lot lately. It'll slow down because as I do this, and I lost it. Where'd it go? There it is. As I zoom in, you're going to see what happens. You guys started to see it right there. Notice you see all that green around it. So as I slowly zoom in, and you notice it's slowing down more and more, it's having more and more trouble calculating those closer and closer values. It really starts to do that oscillation thing where it just starts to blur together. And had I not zoomed in, and notice I'm zoomed in really far. I'm talking like 4 and 5 decimal places in to even be able to see this. And so there's something really crazy, really just weird going on right here in the center, where this limit is being taken at 0. And so it's really hard. If I just looked at it at a quick glance, I would probably say, oh, it's approaching whatever that number is, but wherever that dot was. But in this case, notice there's a lot of stuff going on around it, but you don't really see it. You don't really find out about it until you zoom in really, really far. And so it's just one of those things that you need to be aware of, is that the calculator and even yourself can sometimes be misled by just plugging in numbers. And I'll give you some more information. There's a man by the name of Stewart. He has several different calculus books out there. I used his calculus book when I was in college. But so he actually has a web page devoted to what he calls lies your calculator and computer have told you. If you're ever interested, I mean, it's accessible by a quick Google search, and he'll tell you all about these different lies and things that just doing something your graphing calculator will do, where it's not going to be necessarily what the truth is. Like in this case, if I just looked at it very, very quickly, I didn't see what was actually happening in the real picture. And so that's the thing. Again, graphing calculators are not even as powerful as this app right here, so they would never have been able to have shown you what was going on, this blur in the section. But I hope that helps explain why we're getting ready to do a new method, because it's not those other two methods, the graphical method and numerical method, they're not foolproof. So we're trying to find a new method that's going to be a little bit more accurate, a little bit more correct at those weird moments. Hope this helps. Have a good day.